All right, here we are, 11.1, day number 2. We're going to talk about how many solutions, how many different triangles could we have. The possibilities here, we could have 0 triangles, 1 or 2. There's a couple different scenarios for how we could have one triangle, given 2 sides and an angle, using the law of sines, of course. And there are 2 ways that we could have one possible triangle. One way we could have 0 and one way we could have 2. So we're going to talk about those in a little bit. So let's just talk real quick about this. Using law of sines, how would I find those missing angles? Math. Joey just voluntold an answer. So Joey, I would take the sine of 40 over what? Let's call it beta over 15. And then, so this would be beta, right? And then we cross multiply. Okay. Joey, stop. Okay, so we'll just call it beta for now, but it'll be the answer to part A, right? I think, well, yeah, it'd be the first one, right? Yeah. So that angle, if we cross multiplied and solved and did the inverse sine, we'd get about 28.8. Now, someone is going to do this, and they're going to spend an extra probably 3 or 4 minutes on the test that they don't need to. What is someone going to do? Law of sines again. Fail. Don't do that. Take 40, and what we know is now 28.8. Add them together, subtract from 180. Don't be the child that does law of sines twice. Don't do it. Don't do it. Okay, somebody's going to do it, but don't. Don't be that person. If you add it together, subtract from 180, you should get 111.2. Okay. Again, this is another case where we're going to have a problem. When we cross multiply this using law of sines, we're going to have an issue because the triangle doesn't exist. Okay, that 8 is going to be just not quite long enough to reach the opposite side because that angle is static. It's not changing. Continue on to the meat of this lesson here, which is, how do we know? How do we know when there's 1 or 2 triangles or no triangles? Well, the first thing you want to do in all cases is you want to find the height. And yesterday we talked about this formula. We said that the height of any given triangle would be the sine of the angle times the side, right? So actually, I'm just going to write it out based on this. If I wanted to find the height here, I could use the sine of alpha is equal to height, which is unknown, divided by 20. Okay, this is not your height. Your height is this. We're considering this length. We're trying to figure out whether or not it's going to form a triangle. So then our height in this case, and in all 3 of these cases, you'll see on this slide, is going to be 20 times the sine of A, and A is 47. I think, if I'm not mistaken, that comes out to be like 14.6 or something. Will somebody use their calculator and confirm? Yeah? Okay, so if I know that this length right here is 14.6, will that 12 be able to reach that opposite side? No, right? It's going to, this 12 right here, this length of 12 will just kind of, it's just a T-Rex who can't tie its own shoes, right? Can't reach the ground. And T-Rex arms on that one. So we'll talk about the generalization of this in a moment. Okay, so the height is still the same. It's 14.6. Will 21 reach? Yeah, it'll reach, right? What if I went over here? Is 21, well, 21 is just, I know it's not proportional, but 21 is a little bit longer than 20. Therefore, this would not be a triangle, right? At least with that same interior angle of 47 degrees. So in that case, we're only going to get one triangle out of that, right? This dashed line doesn't ever hit that base again. Now, if we have this value of 15, we could say, yeah, of course, that's bigger than 14.6. And what will that do? That will form one of 2 triangles, right? And those triangles would look like this. The first one that we formed, we'll have a 47 degrees there. This will be 15. That'll be 20. We'd call that beta 1. And we could find that using law of sines. The other triangle formed will still have a side of 20, an angle of 47, but then it'll have this obtuse angle here. We're going to call that angle beta 2. Okay. How are beta 1 and beta 2 related? What do you think? How do you know, Mr. Ludd, that they add up to 180? Well, I just do. But also, because if I swing this here to here, that angle and that angle are the same. And the only way for those two angles to work out, I mean, they're just going to be supplementary because they form a straight line. So this would be beta 1, and this would be beta 2, and we would know that beta 1 in all cases plus beta 2 would equal 180. Okay, so let's get to the point. Let's generalize this for a moment. Using the law of sines, you have to be concerned about whether or not A is less than the height, greater than the height, equal to the height, and if it's greater than the height, is it less than that side B? Okay, so what is the height? The height is this. The height is B sine of A. So we said that if A, the side across, is less than the height, here's the height. If A is shorter than the height, how many triangles exist? None. It can't reach. It doesn't reach. Okay. In the second example, same thing. What if A is equal to the height? We'll have one of them. What kind of triangle will it be? Yeah, it'll be a right triangle. All right, that'll form a right triangle. All right. What if A is greater than the height and less than that other side? There'd be two triangles. That's our ambiguous case. That's when we get a triangle that looks like this and another triangle that looks like this. That's beta 2 and that's beta 1. Alpha, of course, won't be changing. Of course, this would be gamma 1 and this would be gamma 2. So gamma and beta will change, but alpha will always stay the same. All right, and then in this last case, if A is greater than or equal to B, all right, we encountered this at first. If this was 20 and this was 21 and this was 47, how many triangles did we say existed? Only one. Only one. All right, because if I take this side and I swing it over here, it wouldn't form a second triangle. What if A equals B? What kind of triangle would I have? Nope. Not A equals height, A equals B. That would mean these two are the same. No, not necessarily. Possibly, but not necessarily. It'd be an isosceles triangle, right? So there'd be one triangle. If A equaled B, it'd be isosceles. Now, Joey, if this were 45, you'd be right on. It'd be a 45, 45, 90. Okay. All right, cool. So one law of sines concern, or a second law of sines concern, is if angle alpha, right, instead of A, I'm going to use alpha. If A is greater than 90, if it's obtuse, then there's really only one of two situations. If A is less than or equal to B, what's going to happen here? Will a triangle ever be formed? No, T-Rex, right? So no triangles formed. If A is greater than B, how many triangles would be formed? One, right? It would only be formed right here. So there'd only be one triangle formed if A is greater than B. That's situationally an obtuse alpha, if you will, if we start with an angle that's greater than 90. All right, so yeah, if you would, how about you take 5 minutes with a neighbor and pick 3 of these. Pick 3. I want you to determine how many solutions, meaning how many triangles are there. We'll come back and we'll review it in a couple minutes. Talk to a neighbor. Go. All right, so as I look at these problems, the first thing I do is I see if the angle given is acute or obtuse. If it's an acute angle, then I find the height. If it's an obtuse angle, I don't find the height because I don't care. All right, obtuse angle, if the side across, right, side across is greater than the side next to the angle, how many triangles exist? One. Right, so one triangle here. How many triangles would there be in example 5? 0. 0 triangles, because this side 200 is not going to be able to reach because the side next to it is 600. It's just going to T-Rex it. right? If you can't visualize that, here's an obtuse angle, right? Here is 600. Here's a 200. It's not going to be able to reach, right? That obtuse angle does that to it. Up here, here is the obtuse angle, 150. Here is 5. Here is 3. Right? That 5 would be able to reach, right? Okay, so that's the first thing I do. I look at the angle. Is the angle greater than or less than 90? If it's equal to 90, then what's the point? I just use SOHCAHTOA, right? Okay, so from there, now I look at a diagram over here, and I look at the 3 values, and I put the height in the middle. Okay, so the height is about 5. Is that greater than the side across from it? Oops, I'm sorry. Hold on. I wanted the side across in the middle. Sorry. Is that greater than the height? Yes. Is it less than the side across from it? Or next to it? Yeah. So if it's greater than the height and less than the other side, then there's 2 triangles. That's the ambiguous case. Okay, let's look at example number 2. Let's place in there the height and the other values as well. Okay, so height is 23. Side across is 117. Well, that's obviously greater than that. What about B, 30? How many triangles will there be? There will only be one, because this 117 is greater than both of these, right? It would have to flip around there. So there'd be 1 triangle there. Well, would there? Yeah, there would be. We just don't know the length of that other side. It'd be really long to make up for it, right? Okay. Same thing here, one more time. The height. What is the height? The height is, oh, we didn't need it on number 3. Number 4. The height is 80. Is the side across larger than that? Is 35 greater than 80? No. So we'll have a T-Rex situation. Here's 35. That would be the height, 80. Yeah, that'd be a problem. There'd be no triangles there. No triangles in that case. Let's see if we were right. I'm pretty sure we were. Problem number 1, 2 solutions. 2 triangles, we had that. We're good. Problem number 2, 1 solution. Did we say that? Yep, we did. Problem number 3, we said no, we said 1 solution. Good. Problem number 4, we said 0. Good. And problem number 5, we said 0. Good. We're on it. Okay, I would like for you to skip this slide right here and go to this one. This is going to be an ambiguous case where there's going to be 2 triangles, which means for you, you're going to be doing this. You're going to be finding 6 angles and 6 sides. Oh, that was great. How about that? Alpha. You'll find a beta 1. You'll find a gamma 1. Alpha will not change. You'll find a gamma 2 and a beta 2. All right, so let's set this up actually together because I think it'll be important that you see the way this works. Here's 42 degrees. I've got a side of 17 and a side of 23.5. How did you know, Mr. Ludd, that this was going to have 2 triangles or 2 solutions? I just knew. Okay, so I'm going to find the height first. That height would be this, which would be, what would that be? Sine of 42 degrees times 23.5. Will somebody calculate that for me? Just so we can show that this is true. Okay, 15.72. So since this side of 17 is greater than 15.72, and 17 is also less than 23.5, we'll have 2 potential situations. Okay, so you're probably asking yourself, how I'm going to use the law of sines, and I'm going to get an angle. How do I know what angle it is? When you use law of sines, you'll always find the acute version, or the beta 1. So let's use law of sines. Sine of 42 over 17 equals sine of beta 1 over 23.5. So I'd have 23.5 sine of 42 divided by 17 equals sine of beta 1. Will somebody inverse sine this thing? And I'll pause here so we can kind of see what's going on. Somebody find that for me, please. Okay, cool. So in this triangle, beta 1 is 67.6 degrees. I'm just going to round to one decimal place. Alpha was 42, was it? 42. This was 23 and a half. This is 17. Could you find the value for gamma 1? Yeah, add 42 and a half and 67.6, or 42 plus 67.6, subtract from 180. You could find that. You could also use law of sines to find this side, what I would call C. Okay, so then what would the value for beta 2 equal? Because I know these sides aren't going to change. That's still going to be 17. This is still 42. What would that angle be? It would be, say again, 112.4. How'd you get it? Yeah, take 180 and subtract beta 1, and you'd get beta 2. And now you can find the other gamma and the other little c. That's what you got to be careful for. Okay. You got to be careful for the ambiguous case because there's actually two triangles. Here's triangle 1. And when you solve for that triangle, you'll have 3 angles and 3 sides. That says sides, believe it or not. And then this is triangle number 2 that's formed, which will also have 3 angles and 3 sides. Now, you know the sides and angles that were given originally, which are these. This and this and this. That's going to stay the same in both triangles. Okay. Do you guys remember back in geometry when your teacher said, well, maybe you don't remember back this far, that, maybe I should do it this way. That is not a congruence statement. Remember that? This is why. Because of the ambiguous case. Some of you are like, I was hoping he'd spell it the other way around. Yeah, I know. I did that in my student teaching when I was teaching 7th grade class, geometry. And the kids are like, hey, look at what he just spelled. He spelled that. And then nobody learned anything. But, okay, that is not a congruence statement because of the ambiguous case. All right? Would this situation work? For law of sines? Would it? Would that work? Law of sines wouldn't work there, right? That'd be law of cosines. That's what we're going to learn tomorrow. What about this one? Yeah, kind of. It'd just be a lot of work to find the angle using law of sines. All right, then you got a lot of work to do. But law of cosines, absolutely. How about angle side? Let's see if law of sines would work with that one. Angle side. Would that work, law of sines? Yeah. Yep. Angle side is a good. And what it is it's this pairing. It's the side angle pairing. If you have an angle and a side across from it, you can do some work using the law of sines. Okay. All right, that's enough for today. Like, subscribe, comment below. It looks like I got 5,000 followers now.
It's processing.
It's processing. Okay, we're working on it. Yeah, we're working on it. So have a great day and learn something new.